exam. Okay, so we have here, we will be talking now about parametric test and non-parametric test, though I believe I have given you a paunang discussion about these two. This one is very important for us to know what statistical tool are we going to use in analyzing and interpreting our collected data, especially in research. So when you say parametric tests, these are statistical tests class which have specific assumptions about population parameter, or that is what we know the parametric test. So our basis of test statistics here is distribution. Therefore, when you say parametric testing, we have to make sure first that the collected numerical data are normally distributed. Okay, so again, when you say parametric test, number one, you have to bear in mind that the numerical data first should be normally distributed. We will have a symmetrical graph for this. We will have a skewness na hindi positively skewed or negatively skewed. Okay, and then for the types of data, this should be either interval or ratio. Okay, we cannot use parametric testings for data that are nominal or ordinal. So please bear that in mind. Hindi natin pwede gamitin si parametric tests. Marami kasi sila kapag ka nominal or ordinal yung ating data. And our measure of central tendency should be the mean. Therefore, the mean here should be a representative of the center of the distribution. Since we have a normal distribution, so definitely we expect that we don't have outliers or extreme values. And then information of the population completely known. So dapat alam din natin kung ano yung characteristics ng population where we draw our samples. So again, we have here applicability for our variables, especially in research. Diba, we have different types of variables in research, even the dependent and the independent variables, to test either the difference or the significance of this difference and relationship of these variables. We can do parametric testing. So example of a parametric testing is yung isa na na-mention na natin and na-discuss na natin, the Ztest. And then we also have the Ttest, and also for the testing of relationship, we have the Pearson. Okay? Now, the non-parametric tests are the complete opposite of the parametric tests. Okay? So wala tayo ditong specific parameters for our population. So non-parametric test yung tawag natin dito. Now, the basis of test is arbitrary. It does not necessarily require that the distribution is normal. Okay? So para ito doon sa mga collected data that can be positively skewed or negatively skewed. Please take note of that. And at the same time, this is also only applicable for nominal or ordinal types of data. Nominal or ordinal. Remember, nominal yung may classification like demographic profile, sex, male and female. We don't have numerical values for that. Instead, we classify them either male or female. And then yung ordinal, like the Likert scale, though we have numbers here, but these are real numbers because we just use the numbers as representative for a specific verbal description or interpretation. And since the data, the collected data is not normally distributed, the mean here cannot be the central of the distribution. Instead, we are going to use the median, which is literally the center of the distribution. And we also use this if we don't have an available information about the characteristic of our population, kung sino man yung tinitest natin. And then this can also be used for both variables and attributes. Attributes, those characteristics that we cannot really measure numerically. So we cannot quantify. Example, beauty. Yung beauty class, wala talagang numerical value for that. Okay, we can describe it through words, but wala tayong data na quantifiable. The same thing with experience. Wala din tayo niyan. And then correlation test, examples ito ha, comparison. Parametric test, we have the Pearson. Ang tawag naman ng non-parametric equivalent is the Spearman. Okay? So if we have satisfied all these parameters here, if we're going to test the relationship between two variables, we're going to use Pearson. But if we cannot satisfy the parameters here, then that's the time we use the Spearman. Okay? So in research and in statistics class, actually ito lahat yung mga test na kailangan nating pag-aralan. And then they are divided into two. These are all under hypothesis testing. So we have to have our hypothesis first before yung ating hypothesis, meron dapat siya before pa mag-run ng test ha. And kailangan exactly ma-determine natin both alternative and the null. Para at the end of research, we can have a decision whether to reject it or not. So kaya nga siya tinatawag na test kasi we are going to test whether our educated guess is true or not. So again, if we are going to satisfy all the assumptions I have mentioned a while ago, this will be under the parametric test. So nakadepende din siya if one sample or two samples. So like one sample, we have one sample Ttest and we are done with the one sample Ztest. And then for two samples, pag independent samples, we are also done with the Ztest, but we will be talking about the Ttest also. Meron din tayong tinatawag na paired samples, kaya meron tayong paired Ttest. Anyway, I'll be discussing all of that para alam nyo kung kailan sila gagamitin. Now, if we cannot use the parametric test since, for example, the data is not normally distributed or the data is either nominal or ordinal, dito siya mafo-fall sa non-parametric test. So examples of non-parametric test, we have here the chi-square, the Kolmogorov-Smirnov, the runs, and the binomials for the one sample. Pero pag two sample, ganun pa rin, it can either be independent or paired. So chi-square is still here. The Mann-Whitney, the Kolmogorov is both for one sample and two samples. Let's not talk about the median. The paired samples we have here, the Sine, Wilcoxon, McNemar, and even the chi-square is still used here. I don't know if you have heard this test in your high school years, but yung pinaka-common talaga si Ttest, si chi-square, and Mann-Whitney and Wilcoxon are also used, even the McNemar. Okay, so let's talk about the difference between the Ttest and the Ztest, because take note, they are both under the parametric test. We also have one sample Ttest and then meron ding one sample Ztest, and that is also true for the two samples. Meron tayong two samples Ttest and meron din tayong two samples Ztest. Again, let's see here, when are we going to use the two? Now, the first question that you need to ask is, do you know the population standard deviation? Okay? Pag alam natin ang sa population mismo ha, hindi sa sample, sa population mismo na standard deviation, dito tayo, if yes, first you ask if the sample size is above 30. Remember, the Z-test is only used if you have more than 30 samples. So again, use the Z-test here if the sample is above 30 and you know the population standard deviation. But even if you know the population standard deviation, but the sample is less than 30, you use the Ttest. Okay? Use the Ttest here. Kapag hindi mo talaga alam ang standard deviation ng the whole population, that's the time automatically you use the Ttest. test. Okay, so that is the reason why Ttest is mostly used in research than the Ztest. Kasi most of the time, we actually don't know the population standard deviation, especially if the population is very big, like the whole Philippines. Our, what do you call that? Our target respondents are all Filipino citizens currently residing in the Philippines mismo. So pila ta ka milyon-milyon. And about a certain topic ha. And most likely we don't know the standard deviation here. And again, that is the reason why mas sikat si Ttest, mas ginagamit si Ttest compared kay Ztest. Okay? So do not be nervous about this chart, though this is like kung first mo siyang tingnan is a bit complicated, but this chart is actually helpful for the statisticians and even the students sa atin to know kung ano talaga yung statistical tests na gagamitin. Okay? So ito yung ginagamit ko to decide anong test yung gagamitin ko to compute for my collected data so that I can analyze and interpret the numerical data, and at the same time I can have my conclusion in my research. So take note of the parametric assumptions ha. Later, na-identify naman dito sa graph saan yung parametric and saan yung non-parametric. Pag parametric, do not forget that you will have independent unbiased samples. The data should be normally distributed and will have to have equal variances. So ito yon, dito tayo magsa-start. Before you can do statistics class, you have to properly identify what type of data are you going to collect. If it is continuous, dito ka sa left side of the chart. If it is discrete or categorical, like nominal data, as babae, lalaki, tapos educational attainment, graduate sa high school, graduate sa college, di ba? We don't have numerical data for that. Instead, we will be placing them under these categories. So kapag ganun yung data mo, automatic, we will be using the chi-square test both for 1 and 2 samples. Okay? Pero minsan lang naman tayo, actually may mga researchers talaga na wala silang numerical data, so categories lang. Kaya makikita nyo si chi-square in their data analysis. But if we have real numbers class, we have here continuous, dito tayo. And nakadepende siya sa type of question. I hope you can still remember your research in your high school days. Meron kayong research asking for the significant relationship. Meron din namang studies that will ask significant difference. Okay, example, is there a significant relationship between knowledge and practices? Okay, example, knowledge on COVID-19, may relationship ba siya sa pag-practice doon sa yung mga ways of prevention natin, mag-mask ba, mag-wash ng hands, and so on. Yan yung example. Is there a significant relationship? And then there are also studies asking for differences, just like what we had for the discussion sa Ztest, since Ztest is used for testing differences. Meron bang difference ang drug A and drug B? So again, yung statistical tests na gagamitin natin is dependent on the type of question. So, if you're going to make your research pohon in your third year, if you have a question asking about significant relationship, ito yon. Dito ka sa left side. Next, the next question that you're going to ask is, do you have a true independent variable? Remember, in research, meron tayong conceptual framework and meron tayong tinatawag na independent and dependent variables. Si independent variables, ito yung minamanipulate natin. Ito yung kino-control natin in research. And then si dependent variable, ito yung outcome. Ito yung mini-measure natin. For example, we want to know the activity of drug A and drug B sa blood pressure. So yung ating independent variable will be drug A and drug B kasi minamanipulate natin siya sa study. Meron tayong set of subjects na bibigyan ng drug A, meron din tayong drug B. Tapos yung outcome natin is yung blood pressure nila. So pag meron tayong true independent variable, we are going to use regression analysis for the test of relationship. Pero pag wala, we will do correlation analysis. And this time, you have to decide whether to use the parametric test called Pearson's R or magna-non-parametric test tayo which is called Spearman's rank correlation. So again, paano natin malalaman if parametric or non-parametric? If we are going to satisfy these parametric assumptions here sa taas on the left side, then we can use the Pearson's R. The number one thing is dapat normally distributed ang data. And then pag hindi, we will be using the Spearman's R or the Spearman's rank correlation. Okay? Ito lang yon for the testing of the relationship. Mas marami yung testing ng difference. Okay? So please take note of that. Mga names pa lang muna, hindi pa tayo magko-compute. Hindi pa tayo gagawa ng conclusion. Isa-isahin lang natin kay Muratag bubuang ani sa kadaghan, no? So, isa-isahon lang be familiar with the names first of the tests na available sa statistics. Now, dito tayo sa right side. Now, we have here testing of differences. If we're going to compare one group or to another group or even we are going to compare a lot of groups, pwede yon sa statistics. Now, may nakalagay dito arrow test for equal variances para lang to ma-identify natin with whether we are going to use the parametric or the non-parametric. Ito yung mga different tests for equal variances. Dapat kasi equal yung variance ng both groups. Diba? Example, meron tayong two groups na kino-compare. Dapat equal yung variance nila. So we have F-max test, the Brown and Smith test, and the Bartlett's test. And then actually we have the Levine's test for the Ttest. And then take note that we are going to use the mean here, mean ng bawat grupo for the differences. Diba? Even in the Ztest class, we use only the mean scores, the average scores of each group. Yun lang yung kukunan natin ng difference. Okay, difference tayo ha. Now, the next question that you are going to answer is how many groups? How many groups yung i-compare natin? If two groups lang class, if na-satisfy natin yung mga assumptions here sa taas, you use the parametric test, either the students unpaired Ttest or the paired Ttest. Pero pag hindi na-satisfy yung mga assumptions, two groups ito, we will be using the non-parametric test which is called Mann-Whitney U or the Wilcoxon rank sums test. Okay? This is for the two groups ha, two groups lang yung i-compare natin. Okay, dito yan siya mag-fall. Pero if yung research natin is maraming grupo yung kino-compare natin, more than two groups, pag na-meet natin yung mga assumptions sa parametric test, that's the time we use the ANOVA. ANOVA is a very well-known test for statistics, no? Parati itong na-mention. So I hope by now, alam nyo kung kailan ginagamit si ANOVA. ANOVA is a statistical test used to determine the differences between more than two groups. For example, may study about anti-diabetic drugs. So meron silang tatlong grupo. The first group is the experimental group. Ito yung binigyan ng drug new drug for diabetes. And then meron silang positive control group. Ito yung group na bibigyan ng anti-diabetic drug that is already available and tested. Just like metformin, pinaka-common na example para sa diabetes na metformin. Tapos yung third group nila is yung parang placebo or parang negative control. Okay? So tatlong grupo yan siya. Meron silang tatlong group of respondents or subjects bibigay nila yung bawat treatment dyan and then after i-compare. So hindi na pwede si Ttest doon kasi si Ttest is just for comparison of the two groups. So 3 groups ito kaya ANOVA kapag na-meet natin itong assumptions. Okay? Now after testing the ANOVA, we can do further test. This is the so-called post hoc test. I will not discuss this kasi hindi pa ninyo makukuha ito. Just take note first about ANOVA. But pag hindi na satisfy yung mga parametric assumptions, yung non-parametric equivalent ng ANOVA is called the Kruskal-Wallis test. And just like the ANOVA, may ano pa siya, further testing. If there is a significant difference between the groups, that's the time we do further testing for both ANOVA and for the Kruskal-Wallis. Okay? Any question? Ano pa lang yun ha? Kaunang discussion pa lang yun. Getting to know the available tests in statistics. Sa isahin lang kay para hindi dili pud ninyo malisang sa kadaghan. Walay gustong i-clarify. So, let's start. Testing differences between means. Dito muna tayo. Differences muna tayo. Sa sunod na tayo mag-relationship. Okay, again, testing differences between means. We will be understanding the importance of the Ttest here. Ttest muna isa-isa lang in hypothesis testing. And then, we will do the math for the Ttest. Pero instead of the SPSS, we will be using the JASP here. Okay? And our goal is to really come up with a good decision sa ating research. So let's start first with the Ttest for independent samples. Again, Ttest for independent samples. When are we going to use this test? This is for testing the difference again between two means. Okay, dalawa lang ha, dalawang samples and we are going to test their difference. And remember, yung kaibahan nila ni Ztest, Ztest is used if you have more than 30 na samples. Ito, ginagamit if we have less than 30 samples. And at the same time, the standard deviation for the population is unknown. Okay? Now, the Ttest is under the parametric test, therefore we have assumptions to be met. Ano nga yon? Pinaulit-ulit ko to kanina pa. Number 1, the data should be normally distributed. Okay? Normally distributed dapat. We can know that actually even without making a graph. Okay? I'll teach you that later also. And the level of measurement are expressed either in interval or ratio scales. Okay? Hindi pwedeng nominal or ordinal data dito. Kasi nga, again, this is a parametric test. And this is used when the samples are drawn from different populations. Pwede din ito. Kasi si Ztest, di ba, dapat pag dalawa ang samples mo, both are taken from the same population. Si Ttest, kahit different yung populations, yung samples are drawn from different populations, you can still test the significant difference. Okay? So this is the formula. Tabang mga langit. That is the reason why as much as possible, meron sana tayong either Excel, pwede din naman natin itong gawin sa Excel. And kung wala kayong JASP, pero as much as possible merong JASP. Kasi if we're going to use ito yung problema ko sa manual computation class kay maugmaan ta ni manual computation. Look at the formula here. For the Ttest pa lang ito ha, and meron, di ba may Ztest tayo, dalawa yung formula natin dun sa Ztest. Sa Ttest, ito yung formula natin. x1 minus x2 divided by S sub x1 minus x2. And then, saan galing itong S sub x1 minus x2? Iko-compute pa natin ito kasi separate formula siya. How do we compute for this? This is the square root of the n1s1 squared plus n2s2 squared divided by n1 plus n2 minus 2 times n1 plus n2 divided by n1 times n2. For those who are going to do manual computation, you may write all the formula in an index card. Okay, kasi pag abot sa exam, nalisang na tangtana, nakalimutan tanang formula. So again, okay lang. I'm allowing you to write all the formula in an index card and together with this one. Kaya basig nakalimut taon sa ng x1, ma'am. x1 is the mean of the group 1. x2 is the mean of the group 2. Yung n1s1 squared, that's the sum of squares of group 1. The n2s2 squared, the sum of squares of group 2. And yun, please take note that n1 is the number of observation in groups, meaning the sample size. And then ang N2, ang sample size naman sa group 2. Okay? Let's have an example. Since I have limited time, I'll be teaching you, sino dito yung yung wala talaga, kahit Excel. Kahit Excel wala, as in. Charot. Kasi I don't want to have the manual computation ngayon kasi again, limited yung time ko. So I'll be doing the Excel and the Just. Wala. Meron naman no kahit Excel. Pwede kasi ito talaga sa Excel. Kung hindi pwede si Just. Kasi si Just is only applicable for those na merong laptop and desktop. Okay? Si Excel, pwede naman siya sa cellphone, di ba? Pero medyo mahirap nga lang. Pero let's try. Okay? So let's have an example here. To find out which method of teaching is more effective in improving performance, 2 groups of trainees were randomly chosen for the study. The following scores reflect their performance after the training. So given na dito yung null and alternative hypothesis. So the null hypothesis, the 2 methods of teaching do not significantly differ in improving the performance. This is the performance. Okay? Please identify whether this is two-tailed or one-tailed. Okay? Pa-send na lang sa group chat. And then the alternative hypothesis, the 2 methods of teaching significantly differ in improving the performance. Ano kaya ito? May direction ba ito or walang direction? So are we going to use two-tailed or one-tailed test here? Kasi just like the Ztest class, the Ttest also, meron din siyang two-tailed and one-tailed. Okay, very good. This one is non-directional. Therefore, we're going to use two-tailed Ttest here. Walang direction, diba? Walang binibigyan ng favor na method of teaching. Actually, hindi nga na-name dyan kung anong method of teaching siyan. Okay, but actually that is experiential teaching and lecture teaching. And ito yung scores. 8, 10, 12, 6, 6, 10 lang ito. 1, 2, 3, yeah, 10. This is the N1 here. And this is the N2 here. Later na yung table ha. Okay. Let me unshare my screen and open an Excel. Ay, sagkalisang. Ulat lang. I'm gonna I'll open my Just also ahead of time. Kaya dugay ra ba ni ma-open ang Just. Tapos pag dili kaya sa inyong laptop or computer, Just maghang pag yun. So open na to siya ahead of time. And what I will do is, wait, I'll copy first yung data kasi memorize yun. Ilagay ko siya dito. Then, padakong na niya. Para makita tanan. And then what's the other one? Lecture. Okay, so ito yung set of scores class after the training. The first group is yung method of teaching given was sorry. The method of teaching given was experiential teaching. So ito yung mostly mga laboratory works where you get to experience doing those things. And then itong isa, lecture. So again, ito yung scores nila after the training sa kanilang performance. If we are going to use the Ttest, lagay ko dito Ttest, ilagay mo muna sa isang box kung saan mo gusto ilagay yung T-score. Okay? The T-score here. So, click the FX and then ito yung Ttest. Hanapin nyo dyan yung Ttest sa mga functions na yan. I hope you can follow or you can review this. I'll give you the recordings of this para makareview kayo. Makita nyo na yung Ttest class. Click that. Ayan siya, Ttest. And then click OK. And then the RA1 is for the group 1. You just have to highlight this. Okay? Ayan. That's the RA1. And then the RA2 is for the group 2. Again, you just need to highlight from the first score to the second score. The last score. And then the tails. I have asked you a while ago about the tails. You have to write 1 if this is a one-tailed distribution or a one-tailed test. Or you have to write 2 if it is a two-tailed. And then, na-identify na natin to kanina na two-tailed. So just write 2 here. Okay? Next, for the type of Ttest. Sige, again, type of Ttest ito. You type 1 daw if it is a paired Ttest, 2 if 2 sample equal variance, and 3 if 2 sample and equal variance. Class, we are talking about 2 sample independent Ttest here. Okay? Bakit independent Ttest? Kasi yung group 1 and group 2, different yun sila na subjects. Meron example mga students, selected students under here sa group 1. And dito, different students ito ditong nasa lecture. Pag paired Ttest kasi class, you will have 2 sets of scores pero the same subjects. Example, yung mga pre-test and post-test bitaw, nang before ko magtudlo sa inyo, I'll give you a pre-test. So may score kayo dito sa pre-test. Tapos, pagkatapos kong mag-lecture sa inyo, mag-post test ako. Pero kayo pa rin yon, the same subjects. Kaya yan yung tinatawag na paired Ttest. Dito, 2 sample. So, 2 sample na independent from each other. And we will assume that there is equal variance. Let's not talk about equal variance, unequal variance first. Kasi ibang test yan siya. Non-parametric test yun. So I'll just write 2 here. Okay? After typing 2, click OK. And automatic class, it will give you the T-score. That is the reason why I don't want to do the manual computation ngayon. Let's make our lives easier. Okay? Sa kataas sa formula, the Excel will actually give us automatically the T-score. And what is that? The 0.003. If we are going to get 2 decimals only here, this is actually 0.00. Okay? Or 0.004. Meron lang tayong third decimal. Now, how are we going to interpret this? The T-score. This is the T-score, ha? Please take note of that. Let's go back to my slide. I hope nasundan yon. Okay. Dito natin siya actually titingnan. Wala ko rin yung na-memorize ninyo ni ha. You can also have this printed and during the exam, pwede ninyo ni siya tanawon. Pagbuhatag sa iyo, ano yung ipamemorize na ako sa inyo, ha? Now, remember class, sa Ztest, di ba meron tayong table? Meron tayong table, di ba? Pero ang table kasi ng Ztest, maliit lang yon. Meron lang yung 0.01 and 0.05 and two-tailed and one-tailed. Pagdating kasi sa Ttest, we have to first identify the degrees of freedom. Ito yung nag-inask kanina sa akin. Kailan gagamitin yung degrees of freedom. And then, i-make sure natin kung one-tailed or two-tailed ba siya. And then, hanapin natin dyan kung ano yung, itong nasa taas level of significance yan ha, 0.4, 0.05, and something. Na paano nga kunin yung degrees of freedom? Degrees of freedom class is n-1 if you only have one group. Okay? Pag one group, n-1 yon. Pero pag you have two groups, that is n1 plus n2 minus 2. Take note of that. Now, since this is Ttest, we are comparing two groups. Dalawang grupo tayo dito sa degrees of freedom. And anong gagawin? N1 is the sample size. Wait lang, nakalimot ko pilang sample size ato. 10. Okay. 10 ka scores, diba? Ito may N1 dyan and then may N2 dito. So, this is 10 plus 10 minus 2. 10 plus 10, 20 minus 2, 18. So, the degrees of freedom class is 18. Okay, that's how you compute for the degrees of freedom. Itong isa na formula ginagamit pag you only have one group. You ask question ha if hindi naintindihan. So, ganito ang gagawin natin. 18. Ito yung degrees of freedom natin. And for the alpha or the level of significance, basahin nyo muna yung problem. Pero in the case na hindi nakalagay sa problem, use the 0.05, which is the most common level of significance na ginagamit. Pero hanapin mo muna dyan. Two-tailed test tayo, diba? So two-tailed test dito ka sa 0.05. And then hanapin mo yung critical value nila kung saan sila mag-meet dalawa. Okay? So this is now our critical value. Ito yung tinatawag class na tabular T-score. So again, 2.101. This is the tabular T-score. And at the same time, take note, parehas lang ito sa Ztest class na plus and minus. So either positive or negative man yung result mo, yung number yung kailangan natin. So again, this time, for the given set of data, level of significance 0.05 two-tailed test, degrees of freedom 18, the tabular T-score is 2.101. What is our decision rule here? Ganon pa rin, the same with the Z-test. If the computed T tayo ngayon, the computed T is greater than the tabular T, what are you going to do? Reject the null hypothesis. Okay? So, in the given set of data, our computed T, what was that again? I forgot. Ito, ay, ano yun? Kalimutan ko tuloy. How can I? Ano ito? 0.004. Nakalimot ko. 0.004. And our tabulated T or tabular T is 2.101. So anong nakita natin dito? That the computed T, no, is not greater. So anong gagawin natin? Accept the null hypothesis. Nasundan yon. The computed T is greater. This is the computed T. This is the tabulated T. Mas malaki yung tabulated T. Again, accept the null hypothesis. Ano nga yung ating null hypothesis? the two methods of teaching do not significantly differ in improving the performance. I-accept daw natin ito. Therefore, walang pagkakaiba class yung yung effect ng experiential teaching and yung lecture na method of teaching. Kasi right after the training, most probably the scores of the participant do not significantly differ. Okay, that's the use of the Ttest. Questions or clarifications? Let me check the time. Yes, I still have time for the just. Pero yung sa just kasi iba yung pagka-arrange kasi nito ng ating data. Ganito yung pagka-arrange sa just class. Wait lang ha, ibahin ko siya. I'll copy this first. Lagay ko muna siya sa column dito. And I'll copy this also. Ay, experiential ito. Lagay ko siya dito. Experiential sila lahat. Iba-iba yung pagka-arrange kasi sa just. Dapat isang column lahat ng scores. Tapos isang column yung lahat ng parang independent variables natin. So let me delete this first. Ay, dapat sinama-kompleto. Okay. So ito yung scores nila, 'di ba? After the test, and ito yung method of teaching. Methods. Methods of teaching. So ganito yung pagka-encode ng data pag sa just. Okay? Tapos 'di ba sa just, we have to save it as CSV format. Lagay ko lang siya sa farm stock. And then CSV format tayo here. And then lagay ko lang Ttest. Okay. Tapos share tayo ng screen, mag-open tayo ng just. Open tayo ng just. Ayan, so this one is the just. And then remember, dito tayo class mag-open ng file. And then saan ko nga yun nilagay? Sa pharmaceutical statistics. And then ang binigay ko na name is Ttest. Ito. Open para i-import yung data. So ito na yung data na nilagay natin. Galing ito sa PowerPoint ko ha. 8, ayan, 11 para sa experiential. Itong nasa baba para sa lecture. Okay. Now, saan natin makikita? From the there sa column sa taas, we will see the Ttest. Click that. And take note that we are doing independent samples Ttest. Hindi one sample Ttest na dalawang sample natin dito. Hindi din paired Ttest. Nasabi ko na kanina, paired Ttest is used if we have the same set of subjects or samples. So independent, click that independent sample Ttest class and ito yung lalabas. And itong variables, ito yung class, outcome variable or dependent variable. So ito yung scores here. Ilalagay natin dito yung scores. And remember the methods of teaching, ito yung independent variable natin or grouping variable. As you can see, yung kanyang symbol here is for nominal data. Nominal naman talaga siya kasi 'di ba classification or category siya. So ilalagay natin siya sa methods of teaching. And then, hintayin natin na mag-compute si Just. Ayan. So, we have here now, sorry. It's not the T-score pala ang binigay ng Excel kanina. It was the p-value. I thought it was the T-score. Anyway, later, i-check natin ulit yung result ng Just. It's the p-value pala. Okay, iba yung ating decision rule here pag p-value ang nilagay. Ito pala yung t-score. That is why nagtaka ako bakit sobrang liit. But anyway, that's 3.3. This is the t-score here. And then the df, we have computed this a while ago. It's 18. And then the p-value is 0.04. Pag gumagamit tayo ng just class, we don't need the table. Again, and even the Excel pala, we don't need the table. Ano yung ating decision rule here? If the p-value is less than 0.05, reject the null hypothesis. Okay? Again, our decision rule, if we are going to use the Excel pala and the just, is pag less than 0.05 siya, which is our level of significance, reject the null hypothesis. Pero if it is more than the 0.05, accept the null hypothesis. So as you can see, the p-value, parehas ito na-compute sa Excel kanina. Akala ko that was t-score. Matagal na ako hindi nakagamit ng Excel. This is 0.004. So parehas tayo. And parehas ang na-compute ng JASP and ng Excel. So kaya it doesn't matter kung ano yung gagamitin nyo. So since 0.004 yan and less than 0.05 siya, diba? So we are going to reject the null hypothesis para here. Reject the null hypothesis. There is a significant difference between the experiential and what's the other one? The lecture method of teaching in improving the performance of the students. Okay? So yan yung class, result natin for the t-test. P-value ang tinitingnan. Si t-score, wait lang ha. Si t-score kasi ito yung mako-compute if nag-manual computation tayo. Hindi kasi natin makompute si p-value pag manual computation. So si t-score, ito yung ginagamit to also arrive in a conclusion pero gagamit tayo ng table. Okay? So wait lang ha. Exit ko pala yung Excel, no? Kasi binago ko siya. Pero sa Excel pala, it's the p-value also na binibigay dito. So 0.004 din yun kanina. So ang gagamitin nyo pa rin na decision rule is yung bagong binigay ko sa inyo. If the p-value is again less than 0.05, reject the null hypothesis. Okay? Yan yung gagamitin pag sa Excel. Pero pag manual computation in which hindi ko po siya ipapagawa sa inyo ngayon kasi kulang nga tayo ng time. Ano nga yung given 3.3 kanina, no? 18 na degrees of freedom and 0.05 na two-tailed test. This is 2.101. The tabular T is 2.101 and then yung computed T class na binigay ng JASP pero hindi binigay ng Excel kanina is 3.3. So yung decision rule na gagamitin natin is the same, parehas sa Ztest, na if T, computed T is not equal, greater than the tabular T, you have to reject the null hypothesis. And then the computed T here is 3.3 based lang sa just how walang manual computation. And then ang tabular T is 2.0101. So mas malaki talaga ito. Therefore, we have to reject the null hypothesis. Let me correct that. Kasi nagamit ko kanina yung P value. Okay, reject the null hypothesis. So whether manual computation ito of the t-score or gagamit tayo ng JASP. Either we use the T-score also or the p-value. And even sa Excel, pare-parehas sila ng answer. Reject the null hypothesis. May difference yung scores ng students sa experiential and lecture teaching. Okay? So again, may difference sila. Questions about this one? Greater than. Ano sila? Wait lang. Dito na ko basa. Ma'am, greater than po or less than p-value kung i-reject. Pag t-score ang tinitingnan, ito yung ating yung ating decision rule. Dapat mas malaki yung computed p kaysa kay tabular t before you reject the null hypothesis. Pero kung p-value ang gagamitin, if the p-value is less than 0.05, that's the time you reject the null hypothesis. Okay? Meron tayong exact value here, constant, 0.05. Ito kasi, tingnan mo pa yung table. Ito, 0.05 talaga, that's our level of significance. If the p-value is less than 0.05, that's the time you reject the null hypothesis. Okay? Questions before tayo mag-end? It's already 10:29. I will not let you do the manual computation. Hindi ko yung tinuro. Masyadong mahaba yun. Ang computation nun. Pero ang kinocompute dun, t-score. Again, t-score yun siya. Hindi natin makocompute si p-value doon. So we are really going to use the table if we are going to do the manual computation. Sali sa exam. Let me think about it. Siguro sali yung hindi sa part ng computation and siguro sa sa objective na type, be familiar with the different names of the test and yung decision rules ng Ttest and kung kailan siya gagamitin, saan siya gagamitin na set of data. So yun lang muna siguro. Anything else? Let's have the computation sa midterm na lang para you will have more time to practice. Kasi practice naman talaga ito since this is mathematics.